Hello everyone, I am Suya Shurchan from SC5 ENTC department from Pune Institute of Computer Technology. So here we are going to present our ESD project, that is smoke and temperature detector, along with my teammates, that is Sanket and Vansh. So let's begin. So the basic intention to make the basic use of smoke and temperature detector device is to sense the concentration, intensity of smoke or gases in the surrounding, and to measure the temperature of the surrounding, so as to avoid any hazardous situation if may arise in the public place or at any place. So let's have a look at the equipments that we are going to use first. So here is the Arduino Uno board, which is a microcontroller based board which we are going to use. The next one is MQ2 gas sensor, to sense the concentration of gas or smoke in the surrounding. The next one is TMP36 temperature sensor to measure the temperature. Both of these sensors are analog sensors. The next one is buzzer to make sound if any dangerous situation arises. The next one is LED, then jumper wires and breadboard to make connections. Now let's have a look on the simulation that were performed on the online simulation platform, that is Tinkercad. So let's look at the circuit that we have implemented first. So here is the Arduino Uno board that we are going to use. Here is the temperature sensor TMP36, of which the middle terminal, that is V out terminal, the from which we are going to take input from the temperature sensor. We have connected it to a not pin, which is analog pin on the Arduino Uno board, and here the another one is power terminal, which we are connected to VCC, and another to ground. Same with the gas sensor, the terminal through which we are going to take input from the gas sensor, we have connected it to analog pin A1, and the other three terminals to VCC, one terminal to ground, and one terminal to ground with a resistor to avoid excess current uh, to the gas sensor, to avoid any damage to it. Here is the buzzer, of which one terminal is connected to pin number 7 and the another to ground. The two LEDs that we have used, one is red and the other is green. And the one terminal of the red LED is connected to the cathode one to ground, and another the anode one with the resistor to pin number 4. The green LED, the anode terminal to anode terminal with the resistor to pin number 4 we have connected, and the another to ground. So now let's understand the code for the circuit. So here is the code. So first we have initialized three variables, that is Celsius, gas sensor and buzzer. The buzzer we have connected to pin number 7, so we have written int buzzer is equal to 7. Then in void setup section, as we are going to take input from the gas sensor and temperature sensor, we have initialized pin A0 and A1 with input, and the pin number 4 and 5, which we are connected to LED, and we are going to get output on those terminals. So we have initialized like that, and after that the buzzer we have initialized the variable buzzer. And then here in the void loop section, uh, the first line, that is we have written the Celsius is equal to map analog, that one. So from that line we are going to take input from the analog pin A0, which we are connected to temperature sensor, and we are going to convert that analog read to digital one, and that reading we are going to store in Celsius variable. So we are going to take input, we are going to we are going to convert it to temperature in degree Celsius, and we are going to store in Celsius variable by that formula. After that, the similar with the gas sensor variable, so we are going to take input from the pin A1, which we are connected to gas sensor, and that input we are going to store in gas sensor variable. After that, here serial print Celsius and serial print gas sensor. So we are going to print that output on the serial monitor, the current temperature and the gas sensor at every second. And after that we have used if else statement. So if the temperature is between the range 10 to 33 degrees Celsius, the green LED will blink. On the other side, if the temperature exceeds above 34 degrees Celsius, the red LED will blow. Then the same with the gas sensor. If the same logic with the gas sensor that we have used, the if else statement. So here we have uh, set the limit of 100. So if the intensity or the concentration of gas or the smoke in the surrounding is below 100, the buzzer won't make any sound. But if it exceeds above 100, then the buzzer will make sound to make people aware. And at last we have given delay of 1000 seconds. So now let's look at the simulation, the output of the simulation. So let's start simulation. So here, as the intensity of the smoke in the surrounding was greater than 100, the alarm is making sound, the buzzer is making sound, as you can hear. So as the smoke is getting far away from the smoke sensor, the alarm is not making any sound, but as it moves nearer to the gas sensor, it is making sound. Yes. Let's have a look on the temperature detector now. Now if the temperature here, you can see it is 25 degrees Celsius, but if it exceeds above 34 degrees Celsius, now it's below 34 degrees Celsius, so green LED is blinking, you can see. But as we increase the temperature, the red LED is glowing. If we decrease it below 36, green, and after that the red. To measure the temperature of the surrounding, we have used this. And now let's have a look on the serial monitor, on which we have printing the temperature and the gas content concentration at every moment. So here you can see, yes, so here the temperature is 40 degrees Celsius now. As I increase the temperature, you can see below, before it was 40, after that is a 59, 68, as we have increased it. So we are going to take, we are printing it, the current temperature and gas sensor, the concentration of gas. So as we move gas towards the gas sensor, here you can see before it was 98 and after it was 118, 133. So the concentration of gas that the gas sensor is able to sense is increasing as we have moved this concentration of gas, the amount of gas nearer to gas sensor. And also the buzzer is also making sound. Now I am moving away from it, so here you can see that 89, 90 as it is decreased. So yes, this was the simulation part of the temperature and smoke detector. So this was the basic simulation of our circuit. And at last, the conclusion of the ESD project that we implemented, the smoke and temperature detector. So it is very simple, and anyone with a basic electronics knowledge can implement it at their home, and it has very minimum cost. I mean, the sum of the cost of all the equipments, if we make, then it is not that much expensive. We can, it is affordable one. So the project that we have implemented, smoke and temperature detector using Arduino board, it was very helpful, as using this project we can easily safeguard any public place or any place to avoid any major accidents regarding any fire, regarding any smoke which may harm anyone. And the future scope of the project is that we can integrate this device with the sensor, the actual sensor, the temperature sensor and the MQ gas sensor, to predict if actual fire is occurred. And also we can use any IoT device, we can manufacture any IoT device to generate notifications if fire is detected for any at any public place on our phones. We can form any we can make any app also for that, which will help us even if we are not at that place, and to get information if any hazardous or any dangerous situation arises. So thank you. This was our project, temperature and smoke detector. Thank you so much for listening.